For this lab, you're going to need your 6 small test tubes. For each test tube, you will usually have a blue or white area that you can write on. Please use pencil in that area because it will come off easily, but pen or marker will not. If you don't have a white area, you can use your Sharpie to write the chemical name on there. The disadvantage of using a marker or even a pen is that most of those are soluble in these organic compounds. So this is one that I wrote the name in blue Sharpie, and when I spilled a couple of drops, it washed it away. So that's where using those pencils on the white or blue areas is really helpful. You may have 1 or 2 temperature probes depending on whether you are working with a partner or not, and you'll have a small rubber band. Go ahead and wrap that small rubber band around the temperature probe and slide it up a ways. Then you are going to take a piece of filter paper and you're going to wrap it around the end of the probe. Wrap it as tightly as you can so that it will stay in place as you're pulling it in and out of the liquid. And then you should be able to roll the rubber band down over the paper. It might take a little bit of finagling to make that happen. All right, and you want the end of the paper to be about at the end of the tube. Once you open the tablet, you're going to open graphical analysis. You can use the pen so that you're not touching it with your fingers. And then it should pop up with the choices of how you're going to enter your data, and you're going to collect sensor data collection. Make sure that your temperature probes or thermometers are turned on, and it should just find the ones that are nearby. But if other ones show up, what you need to do is check the back of the probes for the code on them. This probe, see if it'll focus there, says A5N1. And so I'm going to click on the probe for A5N1 and for the second probe that I have. And so you'll see them appear at the top. All right, so once you've done that, you click Done. If for some reason you've connected the wrong probe or the screen doesn't show up, there's this little button down in the corner and you can press that and go back to the same screen. Now, we already have this set up on the tablets for this data collection. So the simplest thing to do is to click on this page, and then we're going to open, as it says in your directions, 09 evaporation. And that should open up the correct mode. And so what we should notice at the bottom is that we've got a measurement in time and the measurement of the temperature going across. So that's ready to go, but if for some reason it doesn't appear in there, you can click where it says mode here, and then you can change it from manual entry to time-based, and you want it to run. I have 300 seconds because that's approximately 5 minutes, and that should be enough for everything, all the data to be collected. Once you have graphical analysis set up, what you want to do is start your measurement. So at the top of the screen, there's the button Collect, and we're going to start collecting data. And we're just going to let it go for a few seconds, even though our temperature probes are still in the solution. And then once the temperatures seem to have settled, then we're going to grab the temperature probe out of the solution, and we're going to tape it down to the counter and just let it evaporate, and we'll do that for both of them. Be sure the end of the probe sticks out over the edge of the lab bench, and that way the material is free to evaporate from all sides of the temperature probe. So you can see that the blue line started to drop first, so that is the measurement from my first solution. And I'm going to be considering these graphs independently, so it's fine that they are looking a little different right now. After your data collection is done, your graph should look something like this, but for some of the less volatile solvents, we're going to see a flatter graph like this. And so for the next part, it's going to be important to make our graph as vertically expanded as possible. And we're going to do that by narrowing the range of the y-axis. So we are going to click on this graph here. That gives us some options, and we're going to edit those graph options. Good idea always to give your graph a title so we know what we're looking at. Graph options. So you can click in here and add a title if there isn't one already. The next thing we're going to do is we're going to look at the y-axis range. So room temperature is about 25 degrees. So we don't need a top temperature that is so high. So we're going to click on this, and we're going to change that to about 25. And then we can look at our graph to see how low the temperature goes. And so this temperature, the bottom temperature is closer to 15. So I'm going to put in 15. So now we can see a little bit better how far the graph has changed. What we're going to be interested in is the temperature where and time where this first started decreasing. So it was relatively flat, and then we took it out, and that's where it started decreasing, and then how low it got. And we're going to try and estimate this area. Now it's not a perfect triangle, but we're going to estimate that area by figuring out the temperatures at different points. Now one thing I've noticed is that my axis on the y-axis is only out to 180, so I want to make sure that that is at 300. I want to take a look at this graph because they're going to show the two different options we're going to have. If we have left our material evaporating long enough, it will start to rise in temperature like this one does, and that rise in temperature is a little more gradual. So we're going to be looking at the minimum temperature. Now we see on the red graph, the top one, it just levels out. So one way to find what our times and temperatures are to use the feature where this line is showing us where we're intersecting. So I can scroll this to where that temperature is dropping, and I can see that that's happening at about 14.5 points, and then just nudge it over until it starts to drop to record that temperature. If you do 14.5 seconds, if you do 15 seconds, that's not going to make a lot of difference because the amount of the time we're using. Then I'm going to pull this over to where I reach the minimum, and I can see 0.8 is about as low as I go, but I want the first point where I hit 0.8. So that seems to be about right there, and so I'm going to write down the 129.5 seconds and the 0.8 degrees Celsius. And so we're going to use that as our temperature drop, but we're also going to try and find the area of sort of this region, sort of triangular region. The temperature for very volatile compounds will drop very rapidly, and so we'll see a big temperature drop. The amount of energy that's required be the same. This is the graph of the propanol evaporation, and we can see that we haven't spread out the graph very much because the temperature change wasn't very much. So I'm going to use my pen to change the Y range. So now I can see the graph is more spread out, and what I'm going to be paying attention to are the points where it started dropping in temperature and the points where it started rising in temperature. So there's this vertical line that where it crosses the graph, it will tell me what each of those data points are. So I'm going to move it over to about where the temperature started dropping. And I'm going to record my maximum temperature, which was at about 19.9 at the top here. And at the bottom, I'm going to record my temperature, or my time, how much time has passed. And so this is my initial time period. Then I'm going to scroll over. Now on some of them you might be able to visually see where the minimum is, but you might have to kind of play with this. This one's got a little blip in the middle, but its lowest temperature seems to be about 14.6, and it goes back down to that, and then it starts rising again right about here. So I'm going to record as my minimum temperature the 14.6, and then if I can get to that last data point, it'll probably be right before this. So right about 459 seconds. And you know, if there are data points that go up and down in there, it probably won't affect it a whole lot.